Good afternoon, evening, or morning to everyone who's joining. My name is Cindy Cafaro, and I'm a senior product marketer here at ThreatX. What I'll be talking through today is a high-level demonstration of how to secure your APIs and web applications by detecting and blocking attackers with confidence, not complexity, using ThreatX. We'll start today with a ThreatX architecture, talking about how ThreatX operates in your network. I'll walk through this diagram beginning on the left. We have your incoming traffic from the outside world. This is your legitimate users, suspicious traffic, and obviously malicious attempts coming in and going towards the right, your origin. The right is representing your point of origin, and this is where ThreatX is completely agnostic with the ability to be deployed to any data center, private or in the cloud. Now, ThreatX sits in the middle with our security container. And what's unique about the ThreatX security container is that we're doing a lot of different things in here compared to other players in the space. And I'll explain exactly how as we walk through all of its operations. First, ThreatX detects misuse and malicious attempts targeting your APIs and web applications in many different ways, beginning with application and API profiling. This is understanding how the application or API is standardly used and identifies differences or abusive behavior. A lot of players are doing this today, but combining this context with the following is how ThreatX is truly unique. IP interrogation is how ThreatX watches a bad attacker. The IP is being tracked to see how it behaves, and if needed, ThreatX will challenge that IP to see how it reacts. How ThreatX is so unique is when an attacker recourses and rotates their IP, ThreatX uses advanced fingerprinting to continuing following that attacker even as they change path or even migrate into a botnet. Spinning up multiple instances of themselves, we can track all of these nodes under one attacker view by taking this approach. Moving on to the SQLi and cross-site scripting analyzer. Everyone uses this, but the biggest difference here is ThreatX detects attempts based on behavior. We're looking for things in the request that could be made into an executable on the back end. A good example is someone uses the sentence, "I am going to select all users from my union." Now that's a benign sentence, and we want to make sure we don't block it like a regex-based solution would, just because it has basic SQL operators like select or union in the sentence. ThreatX uses context and inspects requests to make a logical decision before blocking, significantly reducing our false positive rate near to zero. Behavior in custom binary signatures. This is a capability that ThreatX supports specifically for business logic use cases and to enforce existing block lists. An example of this could be blocking users from interacting with a specific honeypot. Now, flow validation is one of my favorite features of ThreatX. This is understanding what a proper flow of traffic looks like to your environment. Let's say a user navigates to a banking application and attempts to directly access account details versus walking through a login process. ThreatX can block that user because they broke the normal flow of how the application is used. The last one is layer 7 DDoS. This is looking for a bad actor trying to access large uncacheable objects, request it over and over again as fast as possible to eat up all of your computing resources, triggering a denial of service and taking down your website. Now, all of this concludes the detection capabilities of the ThreatX security container. But once we detect it, we have to do something with this knowledge, which brings us to our next two sections, the decision engine and advanced firewall. Once ThreatX detects attacker behavior, that is fed into the decision engine to be analyzed and correlated against other activity in your environment. Attacker behavior is associated to stage and classification. Stage is where the behavior would fall in the life cycle of an attack, like early recon or mapping, all the way up to an exploitation attempt. Classification is based on an attack tactic being used, such as SQL injection or botnet activity. Once behavior is analyzed into a classification in stage, every attacker is assigned a risk score based on their activity. ThreatX uses risk-based blocking to automatically stop high-risk traffic. Risk scores are constantly being reevaluated based on the most recent activity, meaning risk scores will continuously go up or go down based on the traffic that's being seen by ThreatX. Lastly, ThreatX has its own advanced firewall capabilities built into the sensor that include actions like monitoring, blocking, and permanent blocking. What's different about ThreatX blocking is it follows a 3 strikes and you're out process, again, to ensure we're not affecting legitimate users. Like the example we mentioned above, if that attacker's risk score exceeds a certain threshold, ThreatX will automatically block them for 30 minutes, then we'll release that user. If they come back with more suspicious attempts, we'll block them again for another 30 minutes, and at the 3rd strike, they'll be permanently blocked, removing the need for manual response or management. The advanced firewall also supports other unique response actions, such as tar pitting, so slowing down that attacker, making it more expensive to see if they'll go away. Rate limiting, slowing traffic down to a specific, more acceptable rate. And active interrogation, enabling ThreatX to identify advanced bots by pushing a cookie, challenging them, and see if the bot will accept or deny that cookie. All of these analytics and actions is taking place on the ThreatX container before being sent up to the ThreatX platform. Now, let's log into the platform itself and take a closer look at the ThreatX attack dashboard. The ThreatX attack dashboard provides a comprehensive view into all suspicious and malicious attackers and their behavior targeting your APIs and web applications. Users can see traffic metrics are available at the top of the attack dashboard to provide insight into normal traffic volume compared to the traffic being blocked by ThreatX. We can expand this view from the last 30 minutes all the way up to the last 30 days, so users can view the spikes of traffic activity and similarly spikes due to an ongoing attack. Attacker behavior analytics are provided below in the Threat Entities tab. Various aspects about the attackers and their behavior are provided in this table. And we'll talk about this more in just a second. Lastly, the attack dashboard can drill down into the riskiest threat actors across your entire environment or targeting a specific site using the site filter at the upper left-hand corner of the attack dashboard. Administrators can group sites together and similarly filter this dashboard by site groups if desired. As we just mentioned, the Threat Entities tab provides visibility security teams need to quickly evaluate attackers detected in their environment prioritized by risk. As ThreatX analyzes HTTP traffic, the platform extracts identifying metadata, including IP address, user agent, location, and other characteristics to create a profile and identifier for each attacker. Each attacker is assigned a descriptor concatenated with the pirate name, and this helps ThreatX track this attacker as they rotate IPs and hide themselves or make a lateral movement. Security teams can investigate threats by using the search, sort, and filter functionality available in the Threat Entities tab to drill down and view specific attack conditions. For example, last seen is a great metric to sort by and view the most recently detected attacker in your environment and what they're doing. Another is sorting based on match events because it will bring the most active attackers to the top of the Threat Entities table. To view all of the various behaviors being seen in your environment, the description filter will list every behavior being detected by ThreatX and how frequently for the given time range. If your biggest concern is viewing all of the attackers farthest along in their attack lifecycle, filtering by attack state will only show who is attempting to exploit your APIs and web applications. These are just a few examples of how incident responders or security architects can investigate the threats that ThreatX is protecting against. Now that we've talked about the Threat Entities tab, the Top Targets tab features sites being targeted during the given time selected. Administrators can easily see the assets that are being most frequently or aggressively targeted, gaining insight and understanding of their risk profile. For example, we can get a perspective into which assets are being targeted by reviewing the total requests compared to match events and block requests. Match events is each suspicious or malicious behavior being identified that doesn't yet constitute a block. Blocked requests represents every behavior that does constitute a block, whether the attacker behavior was incremented high enough to pass our threshold, or the request itself was obviously malicious. This could include detecting OWASP top 10 or exploitation attempts like SQLi or cross-site scripting. The status code summary is a great health indicator for your site, showing 5XX and 4XX response codes in relation to the healthy 2XX responses. Drilling down into the Terracotta Site 2, we can review which aspects of your APIs or web apps are being hit the most frequently. And unsurprisingly, it appears to be the login endpoint. The top targets view makes it easy for users to investigate threats in your environment focused on your digital assets, not on the attackers themselves. Lastly, the Threat Map tab provides visibility into the location of each attacker and its associated risk. The interactive map allows users to identify how many unique attackers are from each country. Users can hover over a country on the threat map, and a pop-up will display the number of attacking entities originating in that country. Digging in, let's take a peek into how we're tracking a specific attacker over time. ThreatX tracks attacker behavior over 90 days to identify changes in attack patterns, targets, and the evolution of attackers advancing from recon activity to an exploitation attempt. We can see at the top of this page, high-level characteristics about each attacker include their pirate name, risk score, current status, IP, originating location, and user agent. Below is the attacker's timeline detailing when ThreatX detected and began blocking activity, which we can see started at around 5:18. This is when ThreatX blocked this user for 30 minutes, then relinquished their block at 5:48 in the timeline. Another key aspect to highlight in this attacker's activity is the different attack techniques used. Focusing first on risk-based blocking, these blocks are focused on business logic or context focused on blocking that increments or decrements based on attacker behavior. In this request, we can see the user attempted a credential stuffing request, passing in a user's password and token to the application's login endpoint. Another thing to note is ThreatX automatically obfuscates any sensitive data from within the platform. Request-based blocking, this is your OWASP top 10, SQL injection, or cross-site scripting by blocking the request that's obviously malicious. Here, we can filter by request-based blocking attempts to see earlier on the attacker attempted a SQL injection attempt using similar parameters of the password and token. This is a great example of an attacker that has been blocked temporarily by ThreatX. Next, I'd like to walk through how ThreatX has permanently blocked an attacker automatically. Denied Coxswain has been permanently blocked by ThreatX using automated risk-based blocking. We can see in this attacker's timeline, there's been multiple behaviors that have been detected, beginning with January 17th, all the way to January 19th. If we want to see ThreatX responsive actions alone, I can navigate to the Responsive Actions tab to view each blocking timeline, highlighting the separate events in the past 90 days that caused attackers to move through 3 strikes and you're out model. Now, let's take a deeper dive into his targets on the endpoint statistics page. Endpoint statistics showcases every single API that this attacker targeted during his attempts, as well as any non-API identified paths in the application. Here we can see a majority of the attempts were targeted towards this API. However, there was one request trying to attempt to exploit a path in the application that is managing payments. So with that, I like to recap. At ThreatX, we understand that everything's more complex. Your infrastructure itself to the attackers that want to exploit it. The use of APIs has exploded, making attackers' jobs easier and yours a lot harder. In the face of complex attacks, a signature-based approach just won't cut it. It's a game of cat and mouse, and you'll always feel stuck behind. You know you need to be proactive to stay ahead, but you just don't have the time and resources to do it yourself. With ThreatX, confidence is exactly what you'll gain. ThreatX is a managed API and web application protection platform. That means you'll never stress about the next attack coming. You'll know your APIs and web apps are safe with our risk-based real-time protection backed by experts who do the worrying for you. Thank you for joining today's webinar, and learn more about ThreatX by visiting our website or requesting a personalized demonstration.